Learning goals and success criteria are critical pieces of information students need to be successful learners. Students and teachers must hold a common understanding of what is to be learned and what successful achievement looks like. With explicit goals and criteria, students have the beginnings of what they need to become independent, self-monitoring learners. When performing a task to demonstrate their knowledge and skills, students use success criteria to make judgments about the quality of their performance. Success criteria define, for students, what they are striving to achieve, so it is critical to their success that they have a clear understanding of the criteria. Communicating the criteria to students orally or in writing is a sharing strategy commonly used in classrooms.
We're nearing the end of this unit, Unit 2, and as with all of our units, we have a sort of a major task or an assignment that we take on towards the end of the unit. And this task is going to address a number of the things that we did throughout the unit. Looking at our learning goals from this unit, we've been working on for the last few days things such as adding and subtracting polynomials, multiplying polynomials, factoring simple, complex trinomials, perfect squares, and difference of squares, simplifying rational expressions and stating restrictions, and then multiplying and dividing those rational expressions. Let's just take a minute. I want you to read through the criteria there that is part of this particular task. So our task here is to create this algebra domino challenge. So each of these squares that we see here is a specific tile that is part of an algebra domino. So each domino consists of two individual tiles. We're going to simplify rational expressions through multiplying and dividing. And then one of the things we're also going to do is, of course, state all of our restrictions.
Using only an oral or written strategy for sharing criteria means that the needs of students with different learning styles may not be met. Further, when tasks and their success criteria are complex, students may miss or forget important details. Having students interact with the criteria in some way increases the likelihood that they understand the criteria and so will be able to use it to provide the best evidence of their learning. Teachers can use a variety of strategies to help students understand the criteria. For example, discussing the criteria with examples from the task.
Okay, so you've had some time to look through the task and to read through some of the requirements that are there. We're going to discuss a couple sample solutions, and we're going to look at what is involved on your part in order to make this happen. I do have a sample here that is partially completed. So you'll notice that every tile is going to contain one rational expression and one polynomial expression. As you saw from the second step in our task here, is that there are a lot of other requirements that we need to satisfy when building our domino tiles. So let's take a look at those. First of all, it says the expressions you write must satisfy these conditions. So polynomials, numerators, and denominators for each rational function must be quadratics without a constant common factor. So what does that mean, that it has to be a quadratic? Natalie?
It has to have x squared.
Encouraging students to ask clarifying questions about the criteria.
So are there any questions before we take a look at the sample solution about any of these requirements or criteria that we put on the board? Natalie?
Is there like a way that we can do like a step-by-step process for like finding the first R all the way to the second one? Because
modeling the application of the criteria to a sample.
We're going to look now, do they meet those requirements that we've listed here? So for starters, we have a polynomial beside a rational expression. They're on different colored tiles, which means we have to look for what operation to simplify. Are we looking for products or quotients when they're side by side? When they're side by side, Stacy?
product.
Asking students to apply the criteria to a sample.
So you now have a sample solution that's been provided to you, and we have our success criteria checklist that we're going to use for this sample one that I've provided. And you're going to look through that sample and check to see if it meets those requirements. So you can do that now, and I encourage you to discuss or share any differences that you have, or even the similarities that you have, to make sure that you're on track and finding all of the criteria for this particular sample.
They're the rational expressions that are beside each other. You have
then they have to multiply.
Yeah, and you have x minus 5 on the top here, x minus 5 on the bottom
So
here,
then
so
they
they
can
cancel
cancel
each
each
other
other
out.
out.
So that criteria is met.
Alright. And then on the bottom we had two polynomials, and they had to have at least one perfect square, and they're both perfect squares.
So
it works
same
just
stuff for
fine.
that as well. Okay.
Asking students to use the criteria for peer and self-assessment.
And then when you complete your task, you're going to pass it along to one of your peers, and they're going to check yours. And then before you submit it to me, you yourself are going to check your task to make sure it meets all of this criteria.
This segment presented a variety of ways to help students understand success criteria, which the teacher has identified, so that learners are better able to monitor their learning. A powerful way to help students understand the criteria is to involve them in its development. This process is the topic of the next segment of this video.